let's look a little bit more deeply into what stars are composed of, or what they're made of, and how they behave. I'm going to read this article to you, and I want you to make your own set of Cornell notes as I read. Remember, Cornell notes are a way for you to keep track of new information as you read. You should divide your paper into 3 sections. In one section, you're going to keep track of important facts about what you're reading and vocabulary words. So that's like your notes section. In another section, you should keep track of questions. So here's your notes section. Sorry, it's not the most beautiful thing I've ever made, but here's your notes section. And then over here, you should have questions. Remember, these can be either teacher-like questions a teacher might ask you to check your understanding, or there can be questions that you are genuinely wondering about and would like to learn more about. Questions should always start with a question word, such as who, what, where, when, why, or how. Why and how questions tend to be more sophisticated questions that require a more in-depth answer. So why and how questions are going to be the questions that you're probably wondering about as you read. Like, how does that all really work? And then who, what, and where questions are more like just basic fact questions. So if you're writing a teacher-like question, you might want to use question words what, when, and who. Okay, down at the bottom of your notes sheet, after you're done reading the passage, turn your computer away from you so that you're not looking at it. See if you can write a 1-sentence summary that describes the main point of the article. And the reason I say do it when you're not looking at your computer, because you kind of want to test your memory to see what you can recall from the article without looking at it. This will do 2 things for you. You can check to see how closely you were paying attention and understanding as you read. And number 2, it ensures that you're putting the information into your own words and not just copying it from the article. Since you only have to write 1 or 2 sentences for your summary, you should be able to do that from memory without looking at the computer or looking at the article. Okay, let's go ahead and start reading. After the sun sets, take a look at the night sky. On a clear night, you'll be able to see stars scattered across the black expanse that we call our universe. If you're lucky, you might be able to spot some stars that look bigger than others. They shine brighter and attract our attention more than their smaller neighbors do. You might wonder, why are some stars brighter than others? After much observation, scientists discovered the way stars appear to us depends on more than their actual size. It's also about how far they are from us. Therefore, the farther a star is from Earth, the smaller it will appear to us. The closer it is, the bigger it will look. Try to think of the biggest star you've seen in the sky. An easy one, right? The sun. That's because the sun is closest to us compared to all other stars, located at just a short 150 million kilometers from Earth. The next one, that's a tougher question. Many people answer Alpha Centauri, but some don't know that it's actually a cluster of 3 stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Proxima Centauri is 4.24 light years away and closest to our sun. A light year is the distance that light travels in 1 year. We use this measurement because light is the only thing in the universe that maintains a constant speed. However, even though Proxima Centauri is the closest star to the Earth after the Sun, you can only see it with a very powerful telescope. That doesn't make sense. Didn't we just say that closer stars appear larger and more visible? Well, Proxima Centauri is what we call a red dwarf. Red dwarfs are very small, typically having less than half the mass of the Sun. That means they generate less energy than the sun. Most stars burn hydrogen for fuel. Similar to the way a car uses gas for power, a star uses hydrogen for energy. Red dwarfs burn hydrogen slowly, which means they generate little light compared to stars like the sun. Proxima Centauri is the closest star after the sun, but that doesn't necessarily mean it's what we consider close in our minds. To completely understand how far away this star is, let's think about traveling 4.24 light years away. NASA has built one of the fastest spacecrafts in existence, called New Horizons, which travels at about 60,000 kilometers per hour. Even at this speed, it would take the spacecraft 78,000 years to reach the Proxima Centauri from Earth. Sadly, the first few closest stars are not visible to the naked eye at night, which means we can't see them while we're stargazing from our homes or backyards. The closest star we can see at night is called Sirius, or the dog star. While Proxima Centauri is only 4.24 light years away, Sirius is 8.6 light years away. However, since Sirius is so large, almost twice the size of the sun, we can see it in the night sky. So go outside and see what you can find up there. Okay, so that's the end of the article. I want you to pause the video and just make sure that you have definitions for the following vocabulary words in your notes. Make sure that you make note of what a light year is. Make sure that you make note of the fact that light is the only thing in the universe that maintains a constant speed, meaning light doesn't ever slow down or go faster. It is always the same speed. I also want to make sure that you remember, or that you know, that stars use hydrogen for fuel. Hydrogen is an element that we are going to be learning more about this year, so make a note of that. Okay, so now is the challenging part where you're going to look away from the computer and look away from the article and write your summary. Okay, so go ahead when you're done, upload your notes so I can take a look at them, and let me know if you have any questions.